In this final section, I want to talk about three very special functions that come up quite often: the constant function, the identity function, and the absolute value function. So first, the constant function is anything of the form, say, f of x equals some number. So I'm going to be arbitrary now, just say f of x equals c. Now, if I look at the graph of this function, then I have some value c, say here, and the graph says, well, no matter what x is, the output will be c. So it'll go off that way in that direction, as well as vertically that way. So a constant function, f of x equals c, or y equals c, an alternative, right, I could write this as y equals c. So again, because we're thinking of the graph, this is the x-axis, this is the y-axis. Anyways, when you see a function equals a number, then, so f of x equals, an example would be f of x, say, equals 2. This means every input, the output is just 2. So that's a constant function. They're very easy. In fact, I think because they're so easy, oftentimes students get confused by them. The second function is the identity function. And the identity function is just whatever goes in comes out. So if I put 1 in, 1 comes out. If I put 7 in, 7 comes out. So in writing, there would be f of x equals x. Again, it's good to know what its graph looks like, but you've seen this line before. It's the diagonal line xy, and since y is equal to x, then it must look like this straight line, y equals x. These are the points 1, 1, 2, 1, e, root 2, 27, 27, negative 5, negative 5. Those are all points that are on the graph of the identity function. Now, the identity function is very important. When y is equal to x, it can be used to solve problems easily. Also, it is the basis of all lines. So if you know what y equals x looks like, then you can do vertical shifts, horizontal shifts, and adjust its value, multiples of it, scaling factors of it. All the tools you learned in pre-calculus you can do with this, and now you know what the parent function y equals x is, the basis line, then you can move on and adjust for any other equation. So finally, the last important function I want to talk about is the absolute value function, and this function definitely students have a really hard time with, and I'm going to define it two different ways. So let me scroll down, give us some room. And so then the identity function, of course I mean the absolute value function, is the function, say, let me get the right color, f of x equals the absolute value of x. So this is how we write it. And one way to find it is as a piecewise function. Everyone seems familiar with the absolute value. If I put a positive number in, then that same number comes out. But if I put a negative number in, it becomes positive. One interpretation of the absolute value is it's a measure or the distance of how far a particular number is away from 0. So one way we can define it is it's equal to x if x is positive. And it's equal to negative x if x is negative. So this is a nice piecewise way to define the absolute value, and you should check that this actually gives you what you want. If I put in negative 7 into the absolute value, so if I took the absolute value of negative 7, then negative 7, that's our x value. It's clearly less than 0, so we're in the second condition. And so it would be equal to negative 7. So this is negative -7. But two negatives make a positive, and so it's +7. Whereas the absolute value of maybe 3 is bigger than or equal to 0, and so it's just the identity function, 3. An alternative way, and we'll use this other definition for the absolute values, we could define it in terms of the square root function, because we know the square root function only returns positive numbers. So an alternative definition would be the absolute value of x is equal to the square root of x squared. And notice this will also work. So this is an alternative definition. And again, if I looked at the absolute value of -7, that would be the square root of -7 squared, which if I square -7, I get square root of 49, which is 7. Similarly, the square root of 9 is 3, which is our absolute value of 3. So it works in both cases, whether it's positive or negative. So this is an alternative definition of the square root, and we'll use this definition sometimes as well. Both are useful. It just depends on the situation we're in. So let's look at a few or 3 theorems essentially on absolute values that will help us do algebra with our absolute values. So first off, if I have any real number, say, and I look at the absolute value of the negative of that number, then that's the same as the absolute value of a. That shouldn't be any surprise. Multiplication, and we can see why this is true. So the question would be why? Well, we know that -a, using the radical definition, is equal to the square root of -a squared, which is the square root of a squared, which is equal to the absolute value of a. So that shows us that the absolute value of -a is the exact same number as the absolute value of positive a. Similarly, we have that multiplication. If I have the absolute value of a times b, that will be equal to the absolute value of a times the absolute value of b. Again, why should this be true? Well, we can follow in lines again with this definition, since the absolute value of a times b is equal to the square root of a times b squared, which is the square root of a squared times b squared. And the square root has the nice feature that it distributes across multiplication. And so this is equal to the square root of a squared times the square root of b squared, which is equal to the absolute value of a times the absolute value of b. And finally, the third identity I want to show about absolute values is if b isn't 0, because when I look at fractions, then the absolute value of a over b is equal to the absolute value of a divided by the absolute value of b. And you could prove this the exact same way, that the absolute value of a over b is equal to the square root of a over b squared, which is equal to the square root of a squared over b squared, which is equal to the square root of a squared over square root of b squared, which is the absolute value of a over the absolute value of b. So those are 3 identities that we'll need to use for different purposes throughout the semester. So just remember that if I take the absolute value of a over b, that's the same as the absolute value of a divided by the absolute value of b. If I take the absolute value of a product of 2 things, that's the product of their absolute values. And if I have a negative sign or not, it doesn't change the output of my absolute value.